And then I'll give you a little test review checklist at the end. And I think what I will do is, if you want to, I'm going to post it's like an old quiz. It's only going to be on Google Classroom. I'm not going to give you a printed copy. So if you want to work through that, if you feel like you need more, I think if you went through the booklet and you did the homework, you have everything you need. The other units, I do quiz, and I do give you a bit of a test review at the end because they're longer. Okay. All right. So we have this example here. Sphere has a volume of 1475 cubic meters. Right. A replica is made, and that replica has a volume of. So it's definitely an increase, right? You have to look at the numbers. This is an increase. My scale factor better be bigger than 1, okay? Determine the scale factor used. So volume, think of 3D, right? You've got to make sure you understand that. And this is almost like, I will still go new volume original. So I will show my work, I'll show my setup. I don't need you to do this. I would encourage you to do that, but as long as you show me this part right here, where you just set it up correctly. So the new is 988,134.77 cubic meters, 1475 cubic. Right? You cancel out the units. Cancel out the units, and the last step, I like to see this, that you take the cube root of that. It's just cleaner, and you can put the answer right next to it if you'd like. I will do this. I will put, we call them, well, I call them invisible brackets, guys. Anytime you see something like that, I shouldn't even have to put the red brackets in there. You should just know that, right? That it is taking the root of whatever is inside the root. Okay? So, I don't know, by default, I just tend to always just figure out, especially with these calculators, right? I just figure out this is what's inside, and then I just take the root of that. I go math for the cube root, and then I just go copy my previous answer, and I get 8.75 exactly, right? 8.75. Did I talk about, sometimes the calculator gives you a scientific notation? Did I talk about that? Did I tell you the trick? +1? Okay, I have 2 applied classes, 12 and 11. So sometimes in the 12 I have to mention it again because they got pre-cal kids joining, so they don't know the trick, right? So sometimes I repeat myself a little bit. All right, so we are okay because this is an enlargement. That's what we wanted, right? We know that, right? We got to a bigger shape, so K should have been greater than 1. So keep that in mind. All right, next. By the way, yep, go ahead. 21, one last time here. By the way, once you have the scale factor, I told you that that's the key, right? Now I could say, hey, if the shape of the original, right, if that sphere had a radius of this, like 10, right, what would the radius of the new one be? Or I could flip it. If the radius of the new one is this, let's say 30, what's the radius of the original, right? I could jump back and forth now because you have the scale factor, right? So then you just need to make sure it's like, okay, it's radius. This is one dimensional. So it's just K is equal to radius, right? And so forth. Does that make sense? I just can't do too many questions, right? Next, Yeah, this one is important actually. So I want to do the table yet because there's going to be a small table on the test. Okay. So a cargo container has been built using a blueprint. I will call it a diagram. Right? A blueprint. And there's a scale of 1 to 15. No units. Perfect. I can turn that scale into a scale factor by just flipping that and turning it into a fraction. You remember that, right? You remember. I know you do, right? If the capacity of the blueprint, right? Capacity of blueprint is this many cubic centimeters, right? Determine the capacity of the actual container. Determine the capacity of the actual container. Are they asking for the scale factor? No, it's given. You're not going to have to square root. You're not going to have to cube root. That's not going to happen in this case. So I'm just going to have to see capacity. And do you see the units? What units? Even if you miss the capacity word, you know that it's cubed units, right? Centimeters cubed, that is 3D, right? So I'm going to start with k to the power of 3. Remember, we're in scale factor territory here. Is capacity of the new over capacity of the original. Oh, Mr. Jackson, you said diagram. Actual, remember it, right? I told you to not mix it up. I just did. So I'm going to redo this. Diagram, actual. So I know the scale factor, so plug it in. Right? Plug it in. Make sure it's to the power of 3. I know the diagram, the blueprint, 588.25 cubic centimeters. And so this is my unknown. It's basically saying, hey, if this is true, then figure out what x is to keep that true. And so you go ahead and this is what I tend to do. I take both of them to the power of whatever. So 15 cubed is 3375. So I don't need to cube 1 because I know it's just going to be 1. And this is x. Okay. Then you cross multiply and divide. So x is going to be 588.25 times 3375 divided by 1. It's going to be a big number, right? So 588.25 times 3375, that's 1985343.75. And what units am I in? Centimeters cubed, right? It didn't ask me to convert it, so I'm just going to leave it like that. Okay, so that's a 3D, we got it. The amount of sheet metal required to build the actual container, right, is this. So sheet metal required to build the actual container is that. Determine the amount of sheet metal, right, required to build the blueprint. So I'm keeping diagram in pink and the actual in green so you kind of see the pattern there. What are my units in? Meters squared, so that is 2-dimensional. So I'm going to use on my study sheet, I'm going to have this one there, right? K squared is area, surface area of diagram, right? Not new, actual, there we go. Smart cookies, everybody here. Okay, so what's my scale factor? Way up there, it doesn't change. I'm going to square that. And then I was given the actual. So that is now in the denominator. See that? You got to watch out for that. And this is my, let's call that y, so we're not mixing up variables. So then I square the whole fraction. If that had been a decimal, then you just square your decimal. You remember the trick? If it's a decimal, over 1. Remember that? I put the over 1 just to see that it's still a fraction. So 15 squared, 225 is equal to y over 139.05. Cross multiply and divide. So watch this. 139 times 1, right? You multiply by 1 divided by 225 because it's a different setup, right? So 139.05, that's 0.618. And I'm in meters squared. Okay? And it makes sense because I'm going back to the one on the blueprint, right? The small one, right? So that makes sense. Gotta kind of hurry a little bit. Sorry, guys. That fire drill was just announced yesterday evening. And I was like, no, I need the 10 minutes. So next page. 20, page 23. And it's not going to be this big on the test, right? It's just going to be maybe 2 lines, 2 rows. But I just want to explain to you. First of all, I want you to use the shortcut up here. Remember that the new is k times the original, and it follows that area of nu. If it's area of nu, what will it be? The shortcut. K what? Squared times area of original. And also volume of nu will be k cubed times volume of original. Same thing, it's just I want you to see that it applies to all 3 versions of the formula I gave you. If we get cut short, guys, this is what I'm going to do. You're obviously going to go home after the drill, right? But I will finish this video during my lunch time, and then I'll post the whole thing. But I'm hoping to do a few lines with you at least, okay? So here we go. You can tell which one is the original, right? I gave it away, right? But the one that's completely filled in is your original shape. And then you've got a bunch of replicas being made. So this is how you would do, for instance, number 1. Okay? If you do question number 1, you're now comparing these 2, right? What do you know of both of them? You have both of their radii, right? What dimension is that in? 1-dimensional, right? Area would be 2-dimensional. Volume is 3-dimensional. So to get my scale factor of the nu, I would just go k is equal to, let's put nu here. It would be the radius of the nu, which is 1.35, over radius of the original. And then you just divide them. 0.18. That's now my scale factor. And it makes sense because a reduction happens, so now I have the scale factor. Once you have the scale factor, you can find the area and the volume just like that. You take the area is k squared times the area of the original. Don't look at the other ones. And so the new area of this shape is 22.90 squared inches. The volume will be scale factor cubed times the volume of the original, which is right here, 1767.15. So you cube it, right? You cube the 0.18 and then I multiply it by 1767.15. So the new volume is, and if I round it, it's this cube units. Make sure you write that down. So this is basically just one of those problems I've been giving you, just compacted into a table. We can do this, guys. So, okay, now you forget about the first one. Done. You're done the first shape. Now we're going to go, hey, there's another replica being made, which is now number 2. So we're comparing original and this one. You got to scan. Which one do you know both of? Oh, you know both areas, correct? So I'm going to give you a bit of a shortcut here to find a scale factor. That is your first go-to. If you don't have the scale factor, you need to get that. It's going to be k squared new over original. So what are you going to do? You're going to square root it, right? Can we just do that here? Are you going to be okay if I do that? If I just square root it here? I hope so. You don't have a choice. I'm just going to go with it. So I'm going to square root that. Oh, what's your problem? What's your problem? I'm going to square root it, and that's 0.60, right? That's just what it is. So I found my scale factor, which is the key, guys. That's the key. Now I'm going to fill in the rest. So if I'm asked to fill in this one, I'm going to say that the volume is what? 0.60 or 0.6 cubed, right? Times the volume of the original. The original stays, okay, on a chart like this. So that's basically 0.6 to the power of 3 times 1766 is 7.15. Cubic inches. And then this one here would just be the radius, would be the scale factor. I don't need to raise it to the power of anything because this is one-dimensional. And then you take the radius of the original, which is 7.5. Just so you know, you're gonna freak out when the bell goes. Even if I tell students ahead of time, it's still. You still have 3 minutes according to that. So this one already has a scale factor, so that one is pretty straightforward, right? So now you forget about the first two. Now you're comparing. It's almost like a new question, right? So the original and this new one, and you're gonna find the missing pieces. Okay. If you want this homework you already did technically. If you want charts, you have to go to the workbook and go to page 11 to 14 basically. And you knock yourselves out. Like I'm going to post the keys to this. This is in the workbook. And I'm going to pause the video here. If you want to, I'm going to go through a checklist in the video. It's going to take 5 minutes. If you want to look at that, just fast forward to the end of this video, and it's going to be there. I will also finish this chart. So you have a finished chart. You have the test review checklist. And I will post the old quiz if you want more. But it's basically everything we've done. We've done converting, right? We did unit rate. Remember unit rate? Which one is the best purchase? We've done scale factors. We've done scales to scale factors. And basically what we did Friday and today is the grand finale, okay? That's going to be the heaviest. What we did Friday and today is going to be the heaviest on the test, right? So keep that in mind. All right, so I'm going to continue this chart as promised. So in this case, I already have the scale factors. So I'm just going to look at the area, right? The area of this new shape. And I'm just going to say that the area is k squared times the area of the original. And so that is 1104.47. And we are in squared inches. To get the new volume, it's 1.25 cubed times this. Make sure cursor comes down, okay? 1767.15. That is 3,451.46 cubic inches. We've done that. Now I'm making a new shape based on the original. So I'm comparing these two. I'm going to go over to the fat, and I realize that I have both of their volumes. Okay, so I will figure out my scale factor first, and I will do the shortcut where I cube root already, because I need to cube root to find the scale factor. So new over original, right? And make sure that is in brackets. So to figure that out, that's always the first order of business, okay? Once we have that, it's inside the root, we get that, and I'm going to go math 4 and then go copy that, and so that's 2.5 basically. 2.5 is the scale factor. And then you go ahead and figure out the rest. So if it's area, right, you just square it, square that scale factor and multiply it by the original. And then I will go over here and say that the radius would be the scale factor to the power of 1, basically, if you want to, times the radius of the original. So it's 1.5 times 7.5, sorry. That's 1125 inches. And then this is 2.5 squared times 706.86. And that's 4,417.88 squared inches. So that's your filled in chart, completely filled in. And remember, figure out the original, which is the one that's completely filled in, and then focus on one row at a time, right? So when you scan your new shape, let's say, and so you want to see what do I have both of. And this, in the very first case, you had both of the radii, so that's just a one-dimensional conversion, right? And so you just divide them, and that's your scale factor. And then you use that scale factor. Maybe I will highlight that, right? Once you have your scale factor, you either square it or cube it. And then next here we found our scale factor, and then you either not, I guess you either just use it as is for one-dimensional, and then here you cube it once you want to find a new volume, right? So it kind of follows you. And now the test checklist, if you will. So I will do this on page 25, okay? So chapter 8, test review. checklist. Okay. So what did we do? We did conversions, right? Unit conversions. So you're going from yards to feet, or from centimeters to inches, and so forth, right? We did that, and then we did rate conversions, right? And so if it's $3.95 for 5 pounds, right? We would like to convert that to dollars per kilogram, let's say, right? And then you would have to do some converting there. Or you have 25 miles per hour, you want to convert that to kilometers per hour, right? So we did a lot of conversions there. Once you know how to convert, they basically work the exact same way. You just got to watch out for unit cancellations, right? Once you have either one of these, right, we turn into unit rate, right? Unit rates. And so it's basically, right, what does that mean? Turn the denominator to 1, right? So the classic one is how many dollars per kilogram, per 1 kilogram in particular, right? How many dollars per 1 pound, right? How many dollars per liter? And dollars, traditionally, typically we put that on top, okay? And so when you have, right, dollars per kilogram, let's say, and it could be, you know, $10 for 5 kilograms, let's say. And then you have another store that sells, you know, for 15 bucks, they sell a 13 pound of whatever, right? It could be anything. So obviously the first thing is convert, right? You could convert this to dollars and pounds, right? And then unit rate, and this one you could go straight to unit rate. Okay? So when you have them both dollars per pound, then you can actually compare and say which one is the best. And this scenario would be the lowest, right? Like whichever one is less dollars per pound is the winner. Okay, so unit rates led us to figuring out the best rate, right? Best rate, and by how much, and make sure that your answer is as a rate. Okay, so we did that. And then you also, any one of these rates, you could use proportional reasoning, right? So you might have converted a rate or gotten it to the units you wanted. Then they can ask, right, if, right, a car travels 30 kilometers per hour, that is actually a unit rate, right? How long, right? How long to travel 50 miles, let's say, okay? So when you're given a rate and then asked for either, in this case, time, right? Or they could give you the time and ask how far you traveled, then you want to set up your proportion, right? So you'd go 30 kilometers in 1 hour. It could have been 30 kilometers in 2 hours, whatever the rate is. And then the 50 miles would have to go here. So when you do a proportion where the equal sign is there, you want to match the units. So the first thing you would have to do is go 50 miles, know that 1 mile has 1.6093 kilometers, right? You first want to figure out what this is in kilometers before you plug it in here. Or, right, like as long as you convert and you have your units lined up, you're fine. And so let me just quickly do that since I already got it going. That's 80.465. I'm going to keep it like that for now. So 80.465 kilometers. That's a 50-mile into kilometers conversion, and then you figure out your time there by cross multiplying and dividing, right? So we did that. We also talked about scales versus scale factors, right? A scale could be 2 to 50. A scale factor, you turn that into a fraction, right? That's 1 over 25, right? And that is 0.04 as a decimal or 4% as a percentage, right? So scale factors can be stated in multiple ways. Different units are okay with scales, not with scale factors. So keep that in mind. We talked about that as well. Then scale factor problems, right? So you have to either find K, right? Use K to determine 1D, 2D, or 3D dimensions, right? So that's the whole diagram over actual, new over original thing, right? So keep that in mind. Area or surface area of new, area of original. K cubed is volume of new, volume of original. Okay. So keep that in mind. These are key to success when it comes to scale factor problems. Keep in mind they have to give you 2 out of the 3. So they either give you scale factor and either the radius or the length or whatever, one dimensional of either one of these, and you have to find the other one, or they'll give you both matching corresponding sides, corresponding areas, or corresponding volumes, and then you have to, when it comes to 2D and 3D, you have to either square root or cube root to actually finally determine your scale factor. Okay. And then last but not least is charts. Okay, make sure you know your charts. And to review, I will post an old quiz. And I would say if you go through this booklet, the work booklet that I gave you, and you've actually done all the work there, you should also be fine and prepared. And that's that. All right. Hope this helped. See you tomorrow.